Okay, Richard and Martin, why don't we go ahead and get started, and we'll go right into what you're going to present today.
Cool. Okay, I don't know why that slide's advanced already. Okay, so yeah, hi. This is a few slides. I was going to talk to you about modifying EDK2 for like using it on the LVFS. So the idea is we put the software bill of materials information into the firmware itself and generate it all at build time. So it sort of sounds exciting. So I've been working at Red Hat for like nearly 15 years. Martin's been at Eclipseum for a couple of years. Martin's going to cover the technical stuff, like the code he wants to change and like the ways he wants to do it. And I thought I'd give you some of the bigger picture. I'm going to talk for like 8 minutes or something, so don't get too worried. I could talk about this stuff for hours, but I'm going to sort of restrict myself down. So most of you know LVFS is this website where vendors upload firmware. Every day, 12 million people download the metadata file for the latest firmware versions, which kind of gives you some idea of the scope we're at now. So since we started a few years ago, we've had over 55 million downloads. But realistically, all of the firmware is mirrored out to like US agencies and Pixar, DreamWorks, all that kind of places. And so we don't actually know the real number. It could be an order of magnitude more than this, which is something that's amazing. It's sort of the idea of this slide is basically to show how many people are using this and how kind of how important it is in the ecosystem now. So the idea of the LVFS is we get the entire supply chain involved, which is why the whole SBOM thing makes sense here, where we'll have the IBV, like AMI, Phoenix, Inside, whoever. They'll be uploading firmware on behalf of the ODM, like Wistron, Foxconn, that kind of thing. And then it could be that the ODM is pushing the firmware to end users on behalf of the OEM, like Lenovo, or it could be that the OEM is managing the QA and then doing all the promotion from ODM to from OEM to users directly. And this is also, go for it.
I think you are not showing your slides.
Okay, can you see the IBV ODMs?
I don't see any screen being shared. Is it my problem?
Screen? Hang on a minute.
Yeah, we even tried this before, and
yeah,
it worked.
It's a team. I hate Teams, like with a.
There you go. Now we can see your slides.
Right. So essentially, right. So 55 million downloads. We have the IBVs, ODMs, and OEMs all working together, and we kind of reflect the whole kind of supply chain on the LVFS as well. So we get like an idea of which ODM is being used for what products and that kind of thing, which whether it's a inside BIOS or an AMI BIOS, etc. We kind of know all that stuff. Since we started, we've got 120 different OEMs using it now, with and I guess 2 exceptions, Apple and Broadcom, which is no huge surprise. But lots of these companies are mandating people use LVFS and FWD. Interestingly, like the commercial stuff starting to work now. So like HP jumped on the LVFS because it had to, because it was losing contracts to Lenovo and Dell. This slide used to say consumer supply chain, but since the start of this year, we've had 2 server vendors which have been testing it, and another 3rd one, which is a bit further behind. And so hopefully by next year, we can have 3 server vendors as well, which would be awesome, mostly using Redfish. Anyway, so Department of Commerce says we have to care about software materials. The last executive order said that critical software had to have software materials for US government, and it was a bit fuzzy when it came to firmware, and there was quite a big opt-out clause for firmware. And I'm talking to US government literally in like, what, 50 minutes, with the aim of the next executive order explicitly including firmware and being very specific about what formats it will be included in. So this is something I really want to push hard, and I don't want the AMIs and the insides of the world to panic when this happens. And so we've kind of been working with them for the last, I don't know, 6 months, 9 months sort of thing, working out a plan, working out a way to do this properly. The best way of doing this is doing it all upstream, doing it in EDK, because if you're using an AMI product or an inside project, essentially it's coming from EDK2. Most of the build system is exactly the same. So if we can push everything into EDK, then we get it in both big vendors kind of for free. And that dribbles out to the ODMs and into the OEMs. So when we talk about firmware on a board, we talk about like lots of different firmware. Like you can't just have like one SBOM. And so we have FPGA or XPU, microcode, FSP, option ROM, Southbridge, all the different PEIs from all the different vendors, because it could be that you have different vendors making different stages. The different DXCs, you can have DXCs like parachuted in from a hardware vendor to the ODM without being built at the same time, or you can have it all being built at the same time, like a la core boot style. And then you've got BMC to worry about as well. And when you have all of these, you don't know any of these answers. And maybe SBOM can solve this. Like, who built it? When did they build it? What libraries did they link against when they built it? Like, what statically linked stuff have you included? What license is it? Is it still GPL, or is there proprietary stuff in it as well? What's the version? Versions doesn't really make a lot of sense when you have like a dirty like AMI Git tree or something, when you've had code from AMI and code from other vendors and it's all smashed together and it's all this dirty and it's been modified locally. The idea of it all being 1.0 doesn't really make sense. And so maybe we have to think about the file hashes, like what were the file hashes of the things that made up this DXE, and what was the tree hash of the trees that made up this project. And so you have to start thinking about all of that stuff as well. The aim here is we want to do something really high level. So you're going to have on the LVFS a pie chart per model, per firmware, which says most of this firmware came from Phoenix, some of it came from Lenovo, some from Wistron, some from Realtek. And the only real way we can do that is embed the metadata itself into the firmware, because stuff gets out of sync. If you have like DXCs being parachuted in from other places, or file volumes being merged at compose time, it doesn't really work when you're generating a PDF at build time, because then you have two deliverables and they very quickly and easily get out of sync. But if we encode all of this stuff into the firmware itself, into the DXCs themselves, or the data sections for like a microcode or something, then we can just extract this, and it's no need to kind of check whether it's valid or not and check whether it's correct, because it's literally the data on the SPI chip itself. So because a lot of the data is common, we want to have this compressed blob, which compresses down all of the SWID data. And so the SWID data we can actually encode in as CoSWID, which is the DTMF spec. And then we can use a wrapper called USWID, which basically zlibs it and allows us to patch it using different things. I'll show you why patching might be useful in a minute. So it might be that AMI is actually building the BIOS, building the DXCs, and then sending them to Wistron, or it might be that Wistron has a source code tree from AMI and they're building the binaries, or it could be that Wistron is building the BIOSes for Lenovo on behalf of Lenovo, and the contract states that you can't say that it's from Foxconn or from Wistron. So there's all this complexity we have to work out, like how real do we want to make this SBOM? Like, do we want this to be like contractually valid, or do we want this to be kind of like sort of do we want to encode the name of the person that's building it? You know what I mean? You can sort of take it to the extreme, and there has to be a balance here. And the way we've kind of balanced that out is requiring the least.
Richard, just a quick question on the kind of the background on the SBOM itself. I mean, I think a lot of the questions you're asking are really good, but the answers to those depend upon how the SBOM information gets used and what a consumer of the SBOM information is going to do with it.
Yeah.
Do they care about that level of detail of supply chain or not? So what's the use case for the SBOM here that can help drive these requirements?
So that's a super good question, and the answer is I don't know. But what I do know is if we try to overcomplicate and ask for everything for every single scenario, the IBVs are going to just say no. So if we can just say, look, who built it? What did they build it with? When did they build it? That's like that information gives us so much information that we can then say, okay, well, this system is vulnerable to this. This system is not vulnerable to this. This system contains code which was from an embargoed country. This code definitely does not have any embargo issues. And so I don't, maybe it makes sense to define how we're going to use it, but I think at the moment, what the easiest thing to do is ask the IBVs and ODMs to provide any data. And then once you've got the tiny bit of metadata that we in the flow, so to speak, actually being built, pushed out to users, we can then say, okay, well, now can you tell us all the information about what compiler you're using, what linker you're using, all that kind of stuff as well. So I think kind of start small and then add, rather than architecture astronaut and ask for everything. Does it answer the question at all?
Yeah, that's a good practical answer.
Yeah, it's like an open source way of doing it. Make us the smallest viable thing, and then slowly build up, build up, build up. Anyway, I'll come back at the end. Martin can give some of the detail. So the idea here is most of the stuff for EDK we already have in the INF file. Even some of the stuff that we don't have in the INF file, we can generate, like the source hashes. We can generate at build time. That's very easy. The vendor, the entity that's building it, like the vendor, that can be specified in like a top level file. It doesn't have to be per DXE. If you're compiling the whole tree and you're smashing the file volumes together, then you'll have two different top level things. And then when you smash them together, it gets deduped. So it's kind of, it all kind of works. And like I said, this is like the bare bones of what we would expect for each like DXE or microcode or something. We're also allowing, rightly or wrongly, the OEM to override things. So like it's baked into a lot of contracts now where you can't have the details from about the ODM when it gets passed to the OEM. And so using UseWord, you can override different stuff and you can add to stuff. So that's kind of useful for real world things, maybe less useful from an EDK building point of view. So another useful thing that I can mention here is that UseWord, you can say, load a package config file, load a override ini file, and overwrite the data in the EFI file. That's a perfectly valid thing you can do. So that's fairly useful. Actually, where to put the data itself in the binaries, like we've already done this exactly this with SBAT, with the whole grub issues. So maybe sticking it inside the COF section is not a bad idea. And it's certainly very easy to compress or sign doing this as well. And all the linking tools already support SBAT. And so we went through the pain for that. So we can just use the same thing for SBOM. This means if all the data is in the firmware that's uploaded to the LVFS, we can extract it all from all different places, build a nice HTML page, a PDF, SPDX export, SWID export with a tarball of SWID files, and make it so the vendors don't actually have to do anything. Like if you're Lenovo, you don't have to spin up a whole kind of like SBOM server, which is doing like crazy stuff. You can just upload it to the LVFS and then use the link, and then sort of that's compliance tick in the box.
Yeah, I have one comment there to challenge the assumption there that you can discover all the PECOF images and extract the section.
Mm-hmm.
We know that many of the firmware volumes are compressed. There are some standard compression, but it could be custom compressed, which you then generically could not extract. And we also support encryption, so firmware volumes can be encrypted, such that the image that gets uploaded to LVFS, you have no chance at being able to extract that information when that operation is done. And that's supported by the PI spec for ways of encapsulating firmware volumes within an entire flash image to support things like custom compression and encryption. So what you proposed of putting it clear down at the PECOF image scope, I agree. It's a place that the information is scoped to the component appropriately, but it's not easily discoverable by external tools looking only at the entire flash image. Yeah,
so that's totally valid. So my answer there would be that I think it makes sense to support most of the decompression stuff, like LZMA type things, because we need that anyway to do the decompilation for the vulnerability detection in the PE files. So we need to do some of that anyway. In the case where it's encrypted, I'd say, yep, sure, totally agree. And the solution there would probably be, you don't have to store the USWID data in the EP files themselves. You could stick it at the start of the volume, like the file volume. Like it can be outside of the encrypted section. You don't actually have to store it in there. The USWID has this magic 16-byte sort of signature. And so when we actually look for stuff, things like microcode, we can't change microcode because it's signed and it's a blob from Intel. And so we just store that somewhere random in the FEH. Sorry, somewhere random in the file volume, which we just look for this magic signature and then we read it there. So you don't actually have to stick it in the blob itself. And I think that's probably the solution for encrypted firmware. Does that make sense?
Yeah, I mean, I think that's the requirement, is there has to be a likely a place in the a easily discoverable from external tools looking only at the flash image to discover the bomb in an unencrypted, uncompressed format there. And I think as long as that style is supported, I agree that the PECOF scoped one is great for things like OS loaders.
Yeah.
And likely UEFI option ROMs and things like that, they're in a standard format. As soon as you get to system flash devices that may have all these other storage formats within the flash device itself,
so
having a standard way
is both. Like you might have your interim step might be when you're doing the compile of EDK, you build it into the COF images for each DXC or whatever. And then when you actually make the images themselves, or you smash the images together, or you do the final file signing step, you strip out all of that COF stuff because it's a COF header. It's nothing crazy, just a COF section. You just strip all that out then, and you put it in just a catenated chunk in the file volume somewhere as the last step before you sort of like, I guess, bless the image.
Yes, yeah, I agree. As long as we have both paths available, that makes sense.
What is interesting is how small the CoSWID data is. Like if you do 300, if you actually do every single thing in EDK and you've got like 300 different DXCs or whatever, and then you compress that down, zlib it using CoSWID, it's like 30K or something, 30 kilobytes. So although some vendors would balk at that, actually that's not so bad, especially when you're selling to US government. It's kind of like they're not buying the cheapy like $300 laptops, they're buying the big expensive ones with the 32 megs of flash. Anyway, I've gone way off topic. The two tools that we're using, like Coreboot is using GoSWID because it's using Go, and in EDK, Martin's proposing using USWID, or maybe he's not. I'll talk about it in a minute. But now, basically, if you talk to Martin, Martin's got all Martin's actually the one who's actually done the prototype and the patch. So Martin, do you want to take over from here? Do you want to share your screen or just leave the screen up?
I don't know if I'm going to share. Maybe it's some question, but I'm good like this. Okay, so the idea is to have a top level ini file with the metadata that will be for all the modules, like the vendor stuff and distributor stuff. I choose to put it in the same directory where the build target is, where you have all the configuration for the building. And then for each module, I in the Python build system, I added a couple of checks to also generate a new ini file with the metadata of each module, which is in the DES file. I think that's what it's called, which has metadata about the module, like the version and name and that sort of things. The biggest challenge that we face is that, as Richard said, the version is probably not very informative because it's like 1.0 for every module, and getting the Git hash of the tree is not very useful because most vendors will have a proprietary Git tree which you cannot trace back. So we thought about using like a checksum of all the sources that contributed to the building a module, a EFI module. Yeah, that was the biggest challenge, to get all the sources that build a file. I'm looking for suggestions in that part. Maybe I can share the idea that I take is to make files with list of files. Let me show you.
So adding slightly to what Martin's saying, one of the things that the IBVs are worried about is that they ship a tree to one of the ODMs. The ODMs change some stuff, like random stuff, build it, give it to an OEM, they ship it, and there's a security issue. And AMI said, no, we don't do this. Or Inside say, no, our setting is this, but it's been changed by the ODM, and there's no way of knowing without the file hash of what is actually building the object.
Can you see my screen?
Yep.
Okay, so for example, when processing the C files, by the way, I just did it for Linux. I know that multiple systems are needed to be supported, but just as the bug, I did it for Linux. So the idea is, for every C file that you found, you create this source file list with all the files, and then when using this usuite tool, you basically run a script that reads all these files and makes a hash out of them. But again, this is kind of complex, and I think it's error prone. You cannot easily check that every file, and only every file that contributed to the EFI module, was used. And even though you can use, maybe you're using some library and your module is only using a function of that library, and you change another function of that library, and then you have a different hash when in fact the source code of the module is the same. So yeah,
And
that's basically
expanding on what Martin's saying. Like, what do we include? Like, what actually is included in the hash? Like, do we include the compiler version? You'd say that maybe that should be a different identity. Okay, right. The linker version, different identity. The header files that you're including on from your system, it's a bit more dodgy.
Mm-hmm.
Yeah, and there's another subtle aspect of the EDK2 build system that was what's called our autogen. We have an autogen.c file and an autogen.h file that's created for every library and every module. And that contains configuration settings, is the way to think about that. From if the platform, at the platform scope, they decide to change the value of a config setting, those trickle down into these autogen.c and h files. So even though the source code of the module and the libraries are identical between two platform builds, the autogen files may be different because of different platform scope settings. So from, the software bomb's goal of being able to know, is there, for example, the source code of this component in this firmware image, is it the same as the source code used to build this same component in a different platform's firmware image? Is there any difference between them or a vulnerability there? Hashing all of the CNH files would not give you the right answer. You have to filter such that you're only using the ones that are actually part of the maintained code.
Just something on the hashes. I don't think it makes sense to say, this is the hash, find me the code that was used to generate this. So like, I think if you build EDK and I build EDK, I think it's fine for us to have different hashes. even though it's exactly the same code. What you're trying to say is, was this built at exactly the same time, and was the source code modified on the same system? So it's not like you can sort of say, find me the code that generated this hash. It's literally a one-way hash function. It's no use for comparing it between different projects, for instance.
Right, but your example of the supply chain of AMI and then their customer making a code change or not, if all they do is a configuration change with no
And the
source
hash
code
would be
changes, the hash would be different. And so then does AMI think they modified the code or not if there's something that pops up as an issue?
Oh, I see. So in that case, I would say if you've made a configuration change to what AMI said, then yes, you made a change, and your hash will be different. And I think that's literally all you can say with hashes, that it isn't, you can't say the hash itself, the value is almost irrelevant. The fact that it's just different is all the information you can take from it.
Okay.
But tell me I'm talking nonsense, that's fine.
No, it gets back to the use case of the information. I know it's like a fingerprint, and you're saying, is the fingerprint the same or the fingerprint different? And you then might have a larger set of scenarios where the fingerprint is different but not meaningful.
Yeah, also valid. I think it makes more sense to encode things like the compiler version or the version of libSSL you're using or something as a separate entity, as like a defined kind of thing in the CoSWID file, rather than trying to infer it from hashes. I think it has to be explicit rather than kind of like going backwards with hashes and stuff. So for instance, if I want to know, is this compiled against a libpng that's affected by this bug, you can use the version number. Which is another thing, because in EDK, most of the versions are 1.0.
Yeah, that's more of a failing on our maintenance of the version and GUID information within the code base. We could have a suggestion to do a better job of that if that would help with this problem space
And
as well.
certainly ref the version number if there's a security bug fixed.
Correct.
Martin, sorry, I interrupted completely.
Yeah, that's mostly it. As I said, it's like a proof of concept yet, but it's like we wanted to make sure that the build system is capable of doing these kind of things, and we think it is. So
how does
polish it.
How does your code change work for when you statically link other libraries? Is the hash of the Dixie driver, is it only the source code of the Dixie driver itself that's part of that hash, or do you combine the hash of that with the hash of all the dependent libraries that it links against?
No, it's only the files in the EDK tree, inside the tree.
On the static linking thing, like the standard SBOM answer for what information should I include, all of it, doesn't really work when you've got like a 16 meg flash chip. So what I've been telling coreboot is only include the libraries of stuff that is security relevant, like image loaders, network protocol packers, unpackers, or whatever. And so selectively, so for instance, in coreboot, there's a way of you to say, okay, well, if you're statically linking against libpng, you import the libpng package config file, and that becomes part of your SBOM, so you know what version it was. We're not doing anything at the link stage. Maybe that's wrong. Like, comments welcome.
Yeah, I think I'll ask Vincent. I think he's online. What do you think, Vincent? What do you think is the right way to generate a fingerprint for a single PIM or Dixie driver?
Yeah, it's the library problem is the big one, right? Yeah, I don't know. I don't know.
So my gut instinct is, at the moment, do something. Like, we include like the tree hash and all the files that were made into this DXE as a separate hash. That's a huge amount of data. Like, we can tell when files have been parachuted in from somewhere else, a different tree, created on a different date, created by a different entity. And then we can start saying, okay, well, we've got all this data. What can we use it for? What are we missing for these use cases? Almost working backwards.
Right, and if I look at like the entire EDK2 repo, the source tree there, And if I were to go count the number of lines of code there that are in libraries relative to components, the PIMs and Dixie drivers and SMM drivers, you know, it may be like even into just a guess, let's say it's a 50-50 ratio. 50% of it is library code, 50% of it is the top level component code that then links against those libraries within the EDK2. That means that your fingerprinting is missing
Half.
50% of the source code.
Yeah, totally valid. So maybe there should be 3 checksums, like link time. So yeah, really good comment. And I'll sort of cycle back to with Martin and Coreboot on this as well, because they have the same problem.
Right. So can you explain again? I always find it useful to look at other software ecosystems to see what they've done for problems, and then see if we can apply that to the firmware space. So like software bomb for application space, where you may have a large number of dependent components. Think about like NPM or huge numbers of C libraries, you know, and things like that. What is the software bomb approach they've taken for that?
So I think you have to be slightly careful comparing apples to oranges. Like firmware, you have a blob where it's almost statically linked, minimal code, and it's usually all coming from the same place at the same time. Like from like a sort of SBOM point of view. So maybe that's comparing apples to oranges, but I think in general, so people are using SBOM for lots of different things. I think the US government probably wants to use it for where is the code coming from, and security companies want to use it for, is this box affected by this vulnerability? And I think those are the 2 big ones, and I think that's probably what they're using for NPN and the like, principal risk, right? Just my gut instinct here is we ask for the least possible information to make a valid SWID document and then work up from then.
Yeah, I think that's the right approach. And, you know, don't try to cover the dependent libraries and others. Just get the basic images and show deltas. And then once it's upstream, then it can be refined over time. And, you know, the 3.0 rule of the world here, right? This is the 1.0, and by 3.0, you may asymptote towards what we need, but get something going first.
Yeah. And at the moment, like all the different IPVs are thinking about this, and none of them want to do their own thing. Like, it doesn't make any sense to do it. There's no point having an AMI SBOM format. Makes no sense.
Right, and you believe this convention is a community thing. It shouldn't show up in a de jure spec. Like the UEFI forum shouldn't dictate this. It should just be really an EDK community consensus around. Right?
Yeah. So something like consensus on something like, if you have fixed a security bug, raise the version number. That would be awesome. That makes SBOM like an order of magnitude more useful. Because all of a sudden you can say to the system, okay, what have you got? What numbers are installed? If it's above this, then it's not affected by this vulnerability.
Right, since we don't really police versions today, really overload the version semantic as an SVN and start using them as such, and then there's some business utility.
Yeah, I think using it as either an SVN or even as a sender makes total sense.
Okay, yeah, I think that's a great suggestion. Yeah. Because then there's some business motivation to operationalize this.
Yeah, because it's a ton of work to add all this metadata unless we use the INF files, but luckily we have the INF files. But saying that it's justifying changing all the version numbers every time you do a security fix, if you can say, look, this is super useful for vulnerability detection, then it's well worth the while.
Yeah, it sounds like it'd be the prime mover to get people around this. Okay.
That's way more positive than I thought. No one's gone, oh God, don't do this.
I'm willing to have anything in there that gives me information about what's actually in the image.
Yeah. So the other frightening thing is like showing people what goes into the sausage is sort of frightening. What do they like? Friends don't let friends know what goes into sausages. So like some people might look at the stuff in the SBOM and go, whoa, which is maybe a business concern. knowing that, hang on a minute, why have I got 27 different versions of microcode? Why have I got an IPv6 stack?
Yes. And then there was another question that came up yesterday in another meeting that we were all in, and that is, how would you guarantee that there was no tampering?
Yeah, so at that point, I don't. So the kind of party line here is, if people are changing bits of flash on your SPI chip, then you have bigger problems than your SBOM being wrong. So use the existing, like if you want to sign it and use it with part of AuthentiCode, go for it. But I don't think it makes sense to sort of say, well, we're going to use this as a way of protecting your SPI.
Right.
Like,
You've already entered the matrix at that point. So
yeah, exactly. There's way more interesting things I can do than change the vendor name.
Right.
Yeah, I think the scenario that's more complicated than that is the fact that you have firmware distribution services like LVFS. And let's say, hypothetically, there's a firmware image that does have a security vulnerability, and the only thing that's done to fix it is they change the SBOM and don't actually fix the code. And there's no way to tell, right? That's the how do you trust the information question.
Well, there's the hash. You have the file hash. So if they literally haven't changed the source code, then you know they haven't changed anything. But then I think there's a lot of reputational damage there. So if you like, in the same way that we're scanning the DXE files for using like firmware hunts, I'm actually decompiling them and looking for the vulnerability fixes to make sure vendors don't break embargo. In the same way, if we find that vendors are just changing the SBOM but not changing the code, well, that's reputationally disaster.
Agreed. Yes, but I'm okay with your position that it's out of scope to do that. And I think from a TianoCore open source perspective, it makes sense to keep it out of scope. And if an OEM is worried about it, or an ODM is worried about it, or a BIOS vendor is worried about it, they can figure out how to add some mechanism to evaluate the trustworthiness of the SBOM material.
Or just sign it. Just put it in the AuthentiCode signature.
Right, but it's out of scope for, I think, I
totally agree.
TianoCore is let them go figure out if they want to go add that feature on top or not.
Things I do not want to do is figure out AuthentiCode.
Well, and that was the other question that came up yesterday was, where does the open source implementation stop and productization begin?
Productization of what, though?
Like having an ODM do something over and above what the open source implementation is.
I think that's fine. Go for it, as long as they're using CoSWID and we can interoperate. Like, for a good example here is, I don't know if I can say the name, but one of the IBVs wants to have the SBOM available in the like F1 setup screen, where you can actually see the SBOM as like a pseudo HTML page with all the different components in, which means reading the data off the flash and showing it. So I think that's totally fine.
Does anybody else have any questions or any more questions?
I think if we can get some like focus on Martin's patch, that'd be awesome. Because I think Martin, you've done a pull request or a patch proposal at the moment, right?
Mm-hmm.
Do you want to paste that in the chat and then you can get some love?
Have you gotten any follow up on the mailing list or anything in discussions?
Yeah, there is a couple of comments that I couldn't address yet. Some people suggesting using the hashes argument of the build, but that was it. Let me find it.
Yeah, Martin's done an amazing job, because like I looked at the EDK2 build system and was like, nope.
Yeah, the changing build rules.txt is not our first choice of places to go hook things in. It understand there are scenarios where it's the only place to do it for depending on what you need to do, but it is the kind of the last place you go for that.
It's the least fun.
Yes. And the other observation is so far as your patch limited to C code, what about things like assembly code or like NASM? We use NASM a lot for one of our assemblers, and also things like ASL sources for ACPI code and some of our other components that are listed, as you found probably in that build rule.txt file. There's different source files that go through different compilers of various types or assemblers or tools, including things like our VFR for HII setup screens and stuff like that. What's your opinion on what source files should be covered in these SBOM outside of C code?
Yeah, I covered, I think, C and mostly assembly. The other ones, I wasn't really sure about them, so I didn't cover them. But
So the ACPI
now that I point them,
I almost argue is a different identity, like something independent in the SBOM that is interesting. Like it has a version number, it has a creator. Yeah, certainly interesting. Add that to your list, Martin.
yeah.
Even if we just get started with just the C and assembly files, that would be, a good step forward.
Oh, that gets us to 95%. Like that's in terms of like the data we can extract out of just having that data, that small amount of asking like all the different DXEs, all the different vendors that have touched it, and just the CNH files gets us 95%. And then we're polishing. Now, I've got to quit. I literally have a meeting with the US government.
Okay, and yeah, I knew you said you had a 17:45 hard stop.
Yeah,
so
sorry.
Thank you for being here, Richard. That's why
That's
I gave
all right.
you this early time, because I knew this would be a great discussion.
Thank
and
you.
I really appreciate having you here today.
On technical stuff, talk to Martin. If you're worried about like the bigger picture, I'm happy to answer questions. Like either email me or tweet me or whatever.
That's great.
Thank you all.
Okay.
Bye-bye.
Great stuff. Thanks.
And thank you, Martin, for taking the time and being here today.
You're welcome. Yeah, really appreciate.
And I
Yeah.
don't know, Martin, if you've noticed the meeting yet, but we have a separate TianoCore meeting on tools and CI. It may be worthwhile for you to come to that forum. That's on our Monday afternoons. I don't know if it's time zone wise, friendly to you. US West Coast Monday afternoon, because you'll get some tools focused developers in that forum on this, and we do have a bit of a confusion right now in that we have tools in two places right now. One is inside of the EDK2 repo in the base tools directory. The other one is in an EDK2 base tools repository, and we're trying to move towards that one as the primary one with pip install of the tools. So that's a good place to kind of talk about your patch, its scope, and where the code needs to be checked in, and who can help you from our tools maintainers get that pushed through.
Okay. Yeah, I will check that out. Let me see the time.
Yeah, it's on the Groups IO calendar, and you can find it on there.
Yeah, maybe it's a little late for me, but maybe I can assist once at least to sync, or every once in a while.
Sure.
Okay. Well, if anybody have any last questions for Martin? Great. Well, thanks again, Martin,
Okay.
for all of this. This has been great to have you here.
Okay, thank you guys for the feedback.
Okay, take care.
Bye-bye.
So I did want to move on. Do we have any event updates? Are there any events that are coming up or upcoming that anybody should know about? Okay, I will take that as a no. And very quickly, do we have any Coverity status updates?
No updates this month.
Okay.
Becky.
And let's see, does anybody else have any opens?
Nope.
I have one open, and that is I am considering moving this AM meeting 2 hours earlier Pacific time to make it a little bit more time zone friendly to European. Are there any arguments for or against me doing that?
There appears to be a bug scrub meeting at that time. That's already in the European focused time zone.
Then I could probably at least move it an hour earlier.
Yeah, that would not conflict with that other EDK2 meeting.
Yeah, because I mean, it was, it was getting close to 5 o'clock for them to attend this meeting. So I want to make it a little bit more friendly anyway. So I think moving this to 8 o'clock then, so that I don't conflict with the bug scrub meeting. Okay. And does anybody else have anything they would like to bring up, anything they would like to discuss, anything like that? Okay, no ARs for once in this meeting. And the next meeting will, of course, be Thursday, August 4th at 8 a.m. Pacific time. And with that,
Okay.
with that, I will stop recording. And